Okay, so this is episode 6 of Programming in C Sharp. There's going to be some mathematics in here, then followed by harder mathematics and binary mathematics. So if you don't understand the harder mathematics and binary mathematics when you get to it in the video, then you can either learn it by clicking an annotation on the video, but if you don't want to learn that, then don't worry about it, go on to the next video. But watch the first half because that's basics and you should know the basics. Um, so First of all, I'm going to show you math rounding, which again, that's pretty easy. Math.round, and then 4.4f. Okay, so this will round the number, and it should round it to 4. Yep. If I'll put 3.5, and see what you get. You get 4, as you might expect. Now, to shock you, if I put 4.5, this should say 4. You might wonder why. This is because it's using bankers rounding, or non-bias rounding. The way to change this is to do midpoint rounding dot away from 0. This will go back to the rounding system that you're probably more familiar with, where 4.5 would round to 5, not 4. So that's the rounding system. It's just because it's treated more fair to have the other rounding system for like banks and stuff like that. But yeah, you can also do rounding to semi-significant figures. So if I put 4, 5, 7, some numbers, and I say f, and then I say I want that to how many 3 significant figures, 3 decimal places actually. Then you can see that it rounds that, and the 7 got rounded to an 8 correctly. Okay, so after that there is math.floor. So this will round a number down. So if it's 3.3f, this will get rounded down to be 3, like a normal rounding. But if this was 3.8, then this would go down to 3 still. If this is minus 3.3, this will still round down, which is down to 4. Well, minus 4, I should say. So keep that in mind for later on when we talk about truncating. And then also ceiling does kind of the opposite. So if you had 2.2f, this would round to be 3, and like 2.7 would be rounded to 3. If we had minus 2.7, then this, using normal rounding, would round to minus 3, but because it's ceiling, it rounds it upwards to minus 2. Now, the difference between floor and ceiling compared to truncation is truncation rounds towards 0. So let's truncate. So if you had 3.7, basically what it does, if it's positive, it floors it, but if it's negative, it ceilings it. That's basically what truncate does. So this floors it to 3, but if it's negative, and then this should go to negative 3. So that ceilinged it, and if it's positive, it floors it. Next, I should show you min and max. So if you had min, you pass it any number of numbers, I believe. No, just 2. Okay, so if you can pass it 2 values, and it'll tell you the minimum of the 2. So 4.4 and 6. It will tell you what's the minimum of the 2 values. 4.4. This is a problem with floating point maths and arithmetic, but don't worry about it. Then max. Of the 2, which should show 6 or something similar to 6. Okay, so that's basically all of the easy stuff. The next stuff is kind of easy. So sine, cosine, and tangent. So if you wanted the sine of 90, which you should know is 1, this won't work because it works with radians. So to convert degrees, this is meant for 90 degrees, into radians, you times by math.pi over 180. And this should make 1 because you've now converted the radians into degrees. So it's 1. So that works with sine, cosine, and tangent. If you wanted the inverse, so arcsine, arcsine of a value 1, which was 90 degrees, then it would give you the radians currently. So that's what it is in radians. So to convert the radians into degrees, you multiply by 180 over math.pi. So that's simple conversions between radians and degrees. Notice the multiplication was after the output of the math.arcsine for this one, and then previously it was the multiplication was inside the thing, and the fraction was flipped for the sine of 90. I'll just quickly show you again. That's what it was like for that, except capital S. So there were also hyperbolic, sine, cosine, and tangent functions. Pretty self-explanatory. If you want cosec, second, wait. So if you want second, cosecant, or cotangent, then you just do 1 over cosine, 1 over sine, or 1 over tangent. So that's pretty much mathematics. If you want to use them functions, then you should know the equivalents in mathematics with the basic 3 trigonometric functions. Finally, there are logarithms. Math.log. So this isn't finally, but it's all I'm going to cover in this video. You could perform logarithms, pretty much, yeah. You do logarithm in the comma, the base. And then if you want a base 10 logarithm, you can do log 10 and then just have the number, and you'll get the values there for that. So if you want to do logarithms, then you can do that as well. Math.log, let's say 32 in base 2, this should produce 5. Like so. And there are also base 10 logarithms, so math log 10, open bracket. This should basically count the zeros, pretty much. 4 zeros. That's what base 10 logarithm kind of does if it's a 1 followed by zeros. But yeah.